Hello, everyone, and welcome to our EPNOE Talks. EPNOE Association is a non-profit organization working with polysaccharides and interested in promoting network between scientists, business, engineers, and educators working with polysaccharides. Today, we are going to start a new series of EPNOE Talks that we call Great Challenges. So we will be, in the next talks, dealing with very important challenges for our future related to food, related to energy, related to transition to the bioeconomy. And today, it's a great pleasure to have with us Professor Ofelia Araujo from Federal University of Rio de Janeiro. Professor Ofelia Araujo, welcome.
Thank you very much for the invitation, Pedro. It's a pleasure to be talking to you.
Yes, I was very impressed with your CV, Ofelia, because as I was talking to you, you have a very nice combination of skills, because you know very well the oil sector, you know very well the fossil fuel, the fossil industry, but also you have a very strong skills and competence on the environmental part, and also you know about biomass. So you combine these three skills. I see here you have had your PhD and master and PhD in the United States, right? In University of Illinois, and also that you have been very active in coordinating different programs. So it's amazing how you combine. You coordinate programs in chemical and bioprocess and biochemical process technology. Then you are now very active on environmental engineering coordinator. So my question, how you manage all these eclectic skills? I mean, sometimes you don't have some, well, how is that for you?
Okay, you just forgot to mention that I started with electrochemistry and it's coming back with blue hydrogen. Yeah, in the United States, I was in the chemical engineering, but my advisor was very much leading the area of electrochemistry. So I was working on organic electrochemistry. So, and it is coming back, this electrochemical thing, it's becoming very important. So how did I manage to go through all these different areas with process modeling and control? So you model, modeling is a framework that allows you to move from one area and the other. And we are right now doing a lot of modeling and system analysis, because there is no single solution for the world problem. Every energy and raw material problem that we have to allocate demand with supply demands a lot of modeling. So from this modeling background, I went through different areas. That's and it's not that I abandoned one to go to the other.
It is very good.
Some concepts from one area to the other.
And Ofelia, you are working at Federal University of Rio de Janeiro. I mean, many people here in Europe don't know very much about the university, but can you talk a little bit about the Federal University of Rio de Janeiro in the School of Chemical Engineering, right?
Okay, yes. It is the largest federal university in Brazil. We have around 40,000 students, undergraduate, and another 15 of graduate students, 4,000 professors. We have 8 hospitals, and we have Petrobras' main research center is in our campus, along with other research centers. We have all the engineering fields in among our specialty, except for aeronautics and very few areas we don't cover. And the chemical engineering area course was the first in Brazil. Most of the chemical engineering education in Brazil was born in the Federal University of Rio de Janeiro.
And you are located in a privileged position also because you there in Rio, you have also these very big oil reserves, right?
Yes. Brazil is like Rio is like the Brazilian Texas. So we have offshore reserves, huge, the pre-salt, and Rio receives a lot of royalties from the oil activity. So the main research fundings that we have come from the oil industry.
Oh, I see. But at the same time, Brazil has a lot of biomass also.
Yeah, that's a big challenge. Yes, Brazil is very, very strong in this. And with the biomass, we have a lot of bio waste, and it creates a lot of research opportunities also, like the biogas and second generation ethanol, lots of alternatives.
Oh, that is
Biorefineries.
for biorefineries. But Ofelia,
Bioplastics.
I would like to hear your opinion because now everybody's talking about this transition away from fossil fuels and go into this low carbon future. So I would like to hear your reflections about what is the direction, what is going to happen to oil. Is it possible for us to say that in 2050 or 2030, we will have a society free of oil? What is your opinion?
Well, first of all, you have to imagine that society is not static, it moves. And politics moves every year. So at the moment, all the political forces are aligned into the direction of moving, phasing out from the fossil fuels. And it is a good thing to happen. It will happen eventually. But the time frame, maybe in Europe, it can be reached in 20 to 30 years. But those countries that rely a lot on oil, like Brazil, I don't think it's going to be a fast transition. Transitions, they take years and years. From coal to oil, it took more than 30 years, and coal is still here. So I believe there will be a future where fossil will have to be sustainable, like with carbon capture and storage and use of CO2 as a raw material. And you have the problem of using wind and solar energy. There is a fluctuation of supply because of climate. You might control the CO2, but climate is something that varies. Sun is not a 24-hour offer supply. So you have the problem of storage, and like Brazil has a lot of hydro energy, and at this moment we have drought time, and there's no supply, so we rely on natural gas to supply to level out, to save the peak of demand. So we should stop seeing fossil as an enemy, but rather an ally in this transition, because there's no option at this moment that could just say, forget about fossils. We can move completely to renewables. It will happen eventually with a lot of research, a lot of innovation.
We see here in Europe, there is a lot of what the politicians say, where it goes and so on, and then what is really actually done, I mean, the actions to be done to make this transition. And we see that there is a sort of disparity there in between what is said and what is really concretely done. I mean, in further steps. I also see, I mean, and here I call your environmental engineering part. I mean, there is also a big, we are having the perception of society about environment is also changing quite fast. But we see record temperatures in the United States now, or in many places that they're very hot. So how do you see this combination? Okay, the fossils will be here, but now we have environmental pressure that is growing and growing. How you see this interaction?
Well, the environment is there and we have to take good care of it. Although many people are investing in going to other planets to produce, maybe in half a century or a century, we'll move to Mars or other countries, this heavy industry, and bring back the products and leave all the garbage out there. But for the moment, we have to take good care of the environment. And the Agenda 2030 of the United Nations is moving every company in their investments, and every consumer now has the good feeling about protecting the environment. So there's no way to propose new technological alternatives if you don't see the impact it's going to have in the environment. We're talking a lot about CO2, but the environment, so you have many categories, many compartments. You have the atmosphere, but you have the earth, you have the sea, the oceans. So whenever you try to take care of one category, you just move the impact to another category. So we have water. Water is a very, very huge concern. And Brazil is very good in this aspect because we have more than 10% of the world's sweet water. So we have to think that maybe avoiding carbon might represent increasing water demand and fighting for the use of water, because it's something that goes into to produce biomass. A lot of water is needed for biomass growth. So you have to have a global view, a holistic view of supply chains and technology. And what happens with politics is they look sometimes at the bench scale that some scientists and somewhere in the world said it's possible to produce, but they forget about the technology readiness level of the technology. So at this point, fossil fuel is the most mature technology to produce energy. Carbon capture with solvents absorption is the most mature stage to capture the carbon that fossil fuels could emit. So we have every alternative, technology alternative has different sustainability degree. So we have to invest in assessing the sustainability, ranking different technologies and say, well, this one is good for this region. There's nothing that's good for entire Europe. Even for Europe, you have regional aspects that should be safeguarded. So society values has some values that has to protect. Human, sometimes you think a lot about the environment and you forget that, well, we are here, make part of this big show, this earth shows on energy, everything. We are the consumer. We change the demand. So we have to think the social aspect, we have to think the environment and the economy. Our environmental program, we are very much into researching on sustainability and making all the, for instance, we have offshore oil exploration, and when you cut the well, you produce drills, and those drills are left on the sea, in the sea, on the bottom of the sea. And now Brazil decided that this decision was changed because of the oil company's pressure on the government, but was to take the drills from the bed of the sea to the continent. and that would change impacts. It wouldn't impact the sea level, but would come to with salt, different salts that could go into the groundwater. So it's a very complex problem. You cannot take one decision based on one aspect.
Yeah, this is interesting. You mentioned about sustainability and how to access sustainability, right? In your point of view, how we can access sustainability from these different technologies. I mean, when we look at polysaccharides point of view, many people think that because we are working with the biopolymer, we have a green technology, we have a green alternative. And many people look at fossils and they say this is a bad alternative. Or many people look at CO2 now, maybe, okay, we can convert CO2, but how can we have a common sustainability assessment so we can compare to say that this is more sustainable than another? How do this works?
Okay, I also mentioned biodiesel. Everyone say biodiesel is much better than diesel, but biodiesel need methanol, and methanol comes from fossil origin, at least mostly for the moment. So we have metrics and indicators like mass efficiency. Like if you have 1 gram to make half a gram, you have half a gram of residues that you produce. So we research on different indicators and how to get to one combination, and how to measure sustainability. Once again, I repeat, it depends on society. Like what you value the most. There is a coral reef that you want to protect, and there is the community of Indians that you need to protect. You need to safeguard the Amazon. So always put together, give different weights to different metrics. So we have to make sure what's important and what we need.
Yeah, I see in your CV you mentioned life cycle analysis. I mean, how you see this implementation of life cycle analysis, because this is actually not a very new topic. I mean, LCA is already for some time around, but how is this implemented? How is this connected to business, for example, and how is this maybe understood and maybe valued by the society? What is your perception about LCA?
Okay, I'll give an example of the biofuels in Brazil. Brazil just has a program that's RenovaBio, like a renewable. It goes into energy, and this program, RenovaBio, it values the biofuel based on the life cycle analysis. So it has a spreadsheet made by the government, and every step in your production chain, your value chain, is analyzed concerning emissions of carbon, water consumption, and other inputs that your process has and emissions that it puts away. So life cycle is getting to value the product now. Your product is made part from the raw material, part from the energy input, water input, and from its environmental performance. Mm-hmm. So life cycle is becoming an engineering aspect. Like for most of our recent past, we just see if it is economical, if the net present value of your investment, the return on investment. Now we have other metrics to combine, and those metrics take the life cycle. Which raw material you are using in your product, what emissions your process will be responsible for, the liability, like for instance, capturing CO2 and storing it in aquifers like Norway does. What will happen if one day those oil companies will just disappear. Who will be liable for the stored carbon? So there are lots of aspects that come into scene when you go
And what
more
about
responsible.
making chemicals with it? I mean, that is for a very interesting question for a chemical engineer, right? From going from CO2, and we have all this thermodynamics involved in going from CO2 back to hydrocarbons. So
yeah, the problem is that CO2 is a very stable molecule that doesn't really want to react. So you have to do a lot of development in catalysis. And for the moment, hydrogen is very good with CO2, now going to methanol. So having hydrogen from water electrolysis, blue hydrogen, could be really a road to the future of having CO2 transformed into methanol or methane, and like cycling its energy back. So it's a way of storing renewable energy like wind energy and solar energy. You can use the excess, the peak shaving, producing hydrogen, and this hydrogen going with the CO2 that the power plant, a thermal power plant would emit. So it's not one against the other, it's one helping the other forward.
Oh, that is interesting. Then I have a question to you about this one helping the other or one against the other, because we are talking about, let's say, transition to C1. We are using C1 as a platform, but then we have biomass. Is it C1 biomass either, or is C1 and biomass? It's only biomass. So what is your view about that?
It's them all. And that's one thing that has to change researchers' mind, nation's mind, if a nation could have a mind. So public opinion, you have to invest in the public opinion, because right now is the black and white, the color, there is either light or darkness. That's not the truth. There is a whole set of solutions for the problem, and we have to accept them all.
And what would be then your solution for the biomass? I mean, we are glad to work with biomass. We think that polysaccharides are beautiful structures. We want to use these for materials, for application in health, in food, and so on and so on. But we know that even also for the oil, the materials part is a small part. I mean, the polymers, the fraction of oil used to make materials is a very small fraction in comparison with fuels. So what is your view for the future of biomass? Brazil has a lot of biomass. We have also here some opportunities of biomass in Europe. So what is your view?
My view is that although all this effort in Brazil with the biofuel, I don't think in a future for biofuel. Renewable is not biofuel. Renewable will be combustionless. So taking combustion out, we have basically food. We have a huge population, the world to feed. That's priority number one. And to make this food, we have a lot of biomass waste. So I believe biomass waste is the number one raw material for doing, for having new materials. So a biorefinery moved by bio waste. And I would go in this direction. Some waste are like from the food industry, you have a lot of wastewater. So going to biogas, and I think that's the way to go. You cannot make soybean to produce biodiesel. It's not sustainable.
Yeah.
Because if you go back into the agriculture, you have a lot of fertilizer, you have land use change. That's very important. What change you would make in land.
So you talk about something interesting. You talk about that the future is combustionless. So you see that the future, the combustion has, let's say, the days of combustion is counted. Well, at least biomass compression. Can you develop a little bit more this point of view?
Yeah, in industry, for instance, in the chemical industry, some technology need a very high temperature. So this will have combustion for a while until we develop some mild condition process. But most of low temperature process would go with electrical sources. And combustion will be left for very few segments, niche. For instance, airplanes. It will stay there. So what you can do, you can go to bioenergy, or like the Brazilian bioethanol program. If you capture the CO2, you have a negative emission. It's not neutral, it's negative because the carbon came from bio origin. So you can compensate this carbon that's emitted by airplanes with the biofuel CCS, what is called BECCS. So we have to see where you cannot avoid combustion and just leave this, the smaller you can, this amount of activity, economic activity that relies on combustion. But transportation, I don't think cars burning biofuels will be electrical. And then it will come the life cycle assessment of this electricity.
Yeah.
Like Tesla, it's a great profit. It's not selling the cars, but selling the carbon credit. But it sells based on the fact that it avoided burning fossil fuels. But where did the energy come from? Does it come from carbon? Does it come from coal, thermal power plant firing coal? It has a carbon footprint. Then I come back to the life cycle assessment that you were interested in. You cannot get rid of life cycle assessment. It's like a liability, responsibility, whatever raw material you decide to consume in your process, you're responsible for that choice. It's like a comparison with drugs. You're consuming your drug in an apartment and you are not killing anyone and you say, oh, it doesn't do any harm, but there is the supply chain that kills a lot. That's dirt. Yeah. So it's this kind of feeling has to go to society in every aspect, from drugs to cars to plastics. Where does this plastic comes from? Is it biodegradable? What harm will it do to the environment? Yeah. It's you have to open your mind now. The problems are.
Also, when you talk about electric cars, the life cycle analysis of the materials to produce the cars, I mean, the metals and so on and so on. Do you think that if this is accessed also together with the fuels, are the cars, the electric cars, also as green as we think? What is your opinion?
Well, it can be greenish. Like you have a metal that you have to buy from a steel industry that captures carbon. So it will go all the way back. The steel industry will have to be responsible to not have emissions. And maybe plastic cars, and you have to compare its performance, its resistance, and then there is a lot of development to do with plastic to have the same resistance. It's great. It's a way to look at the future and say there's a lot to be done, and a lot that we need to get education to change the world.
Yeah, that is actually a very good point, Ofelia. What do you think actually are the skills we will need? I mean, what is the scientist we need for this transition? I mean, you are busy with education. I'm also busy with education. I'm also busy with educating chemical engineers. You also. So what are the skills? Just to give it here in Europe, we are talking about upscaling of skills. I mean, the industry in the future, they talk about upscaling green skills for engineers because they don't have these green skills regarding materials and so on. So what is your opinion about what will be needed? Because, yeah, we educate people, so.
Yeah, we don't even know if there will be jobs or they would need to be entrepreneurs. and create products. And so we are right now changing our curriculum because of it came from the government to decide a new directive for the Brazilian education in engineering. So Fulbright with CAPES, the Brazilian Agency for Education, it chose 8 courses. Our environmental engineering is one. And we are discussing the curriculum and making students more active so that we can train their leadership, their entrepreneurship, thinking the way they think, because most of them are educated to solve a problem, but given the problem set. They are not educated to think the problem and organize the problem mathematically and then apply all their toolkits that they have a lot. Engineers are very rich of toolkits, but most of them are task oriented. Here's the task, give a task to an engineer, and most of them will have conditions to perform the task in an efficient way, some more efficient than others. But we have to make sure that they know how to phrase the problem, to make this problem a question to solve, to apply a scientific method to solve a problem. See what the question is, the methods they have, and feedback the answer to see if the problem was solved. So we have to develop this practice. Like you don't need to go for a master and a PhD to apply scientific method. You have to bring it to the undergraduate level so that we have a...
Do you think that, for example, some training on LCA, or at least, because there are engineers that they don't know what LCA is, I mean, life cycle analysis. Now there is a lot of discussion about sustainability, but also we have a lot of, the discussion about sustainability is not very objective also. I mean, the indicators here and there. So do you think we could incorporate some education regarding life cycle analysis, for example, in some curricula, so people would have an idea that, the product is coming from somewhere and is going somewhere, and how is that?
Yeah, definitely. And what we are doing with the environmental engineering undergraduate course, we got the sustainable design objectives, the goals, SDG, and we identified part of the curriculum. This math curriculum contributes to this chemical curriculum to that, and we are creating tracks. Mm-hmm. So we have a core, 3 years core course in engineering, and then we go to tracks. The students will decide to be good in energy, good in infrastructure, and then built environments, and then we are putting some life cycle analysis training so that they can think in a supply chain and not think in one point.
Mm. I have another question, because you mentioned about the future is, you see a future free of CO2, of combustion, right? What about fermentation in your point of view? Because there is also this big community working with fermentation and talking about bioprocesses, that the future, everything should be done about bioprocess, or more bioprocess should be implemented. So what is your opinion about that? And I'm happy to ask this question because this is also, you are also coordinating a program with the biochemical engineering process. So
yeah, this CO2 from fermentation, it is a very nice CO2 because it's pure. It comes with water. So it's cooling, compressing, dehydration, and then you have CO2 ready to storage. So it comes with the CCS with biofuels, which is called BECCS, and it's negative emissions, like a sink of CO2. So it's a very good question, because this is, otherwise you'd need membranes, you need cryogenic operation, you need chemical absorption, and it adds in energy costs. So the CO2 from fermentation is just compressing and dehydrating, and then you have a CO2 ready for storage.
Ah, that is interesting. Ofelia, I have a final question. So it was very nice to talk to you so far. And I have a final question. If you would be starting today as a chemical engineer, again, at this moment of transition, you have seen all the areas, I mean, fossil here and there. So where you would start? I mean, what would be your tips to our young scientists to be happy and successful in their careers?
Okay, first of all, you have to be flexible, resilient. So you don't know what the future will be. No. It could even be in Mars. You have your plant, chemical plant in Mars. They have a lot of CO2 in their atmosphere. So you can capture CO2 in Mars and convert it to methanol and bring it back to Brazil, to Belgium. So they have to master the tools. They have to develop engineering thinking, not only the task solving tasks. So they have to have the scientific methods and thinking. That's what we have to train them. So whatever biomass or CO2 will be the raw material in the future, if you store CO2 for the next decades, we'll have a lot of CO2 in the future to transform. So you could be an expert in CO2, how to convert CO2, how to compress CO2, so how is the liability of storing CO2. So just be scientific and not repeat science as in the Middle Age, like they were doing with this pandemic thing, and became a science, feudal science. Science in it is like you have to question everything. It is this way, but it could be upside down. And why is not upside down? What would be the goods and bads of taking it upside down? So that's an engineer thought.
Okay, excellent. Thank you very much. It was really a pleasure to have you, Professor Ofelia Araujo from Federal University of Rio de Janeiro. Thank you for joining our EPNOE Talks.